since we were discussing about the properties of the discrete time unit sample sequence. Now, what is a unit sample sequence? As we all know that we studied about the unit impulse function. Now, the unit impulse function in discrete, we call it as unit sample sequence. Unit sample sequence. Now, we have already studied about the property of a unit sample sequence. That is, the first property says that del n is equals to un minus u of n minus 1. Have we studied about the properties of continuous time unit impulse function? Just tell me. Did we study about the properties of continuous time unit impulse function in previous lecture? Have we studied or not? Because I don't remember कि मैंने last time में क्या पढ़ाया था. Yes? We have already studied about the unit impulse function in previous class, and I guess that we have studied about the properties of the continuous time unit impulse function also. So today we are studying about the properties of discrete time unit sample sequence. Unit sample sequence is nothing but the unit impulse function in discrete time. Clear? So in discrete time, the unit impulse function is called as unit sample sequence. Now, for the first property of a unit sample sequence is that del n is equals to un minus un minus 1. Now, this can be easily defined as we know if I'm plotting u of n, it starts with 0, 1, 2, 3, 4, and this is my un, correct? So, this is the un. Now, if I have to plot u of n minus 1, this is u of n minus 1 for the same 0, 1, 2, 3, 4. From where the u of n minus 1 will start? U of n minus 1 will definitely start from 1 because it will shift to left. So, this is how the u of n minus 1 plot would be. All these values are 1. All these values are 1. Now we know that del of n exists only at n equals to 0. Del of n exists only at n equals to 0. If we have to define it, this is 1 for n equals to 0 and 0 for n not equals to 0. This is how the del of n is defined, that it exists only at n equals to 0 and the value is 1. And it is 0 for all the non-zero values of n. So if we subtract these two, u of n minus u of n minus 1, definitely the respective values will get subtracted. That is the value at n equals to 1, n equals to 2, n equals to 3 and n equals to 4. And what is left would be n, 0, 1, 2. This is the value at n equals to 0. Because un has the value at n equals to 0. We don't have the value at n equals to 0 for u of n minus 1. So 1 minus 0 will be just 1. And the rest of the values will get cancelled out. Sub 0 ho jayega. So we can write this as del of n is equal to n minus u of n minus 1. Clear? So that is what is the first property of the unit sample sequence. Now coming to the second property, del of n minus k. It will have the value 1 at n equals to k. And it will have the value 0 when n is not equals to k. So del n minus k will shift to the value k. This will exist. Del of n minus k will exist only at n equals to k, and the value will be 1, and it will have no value at all for rest of the values or values of n. Clear? This is the second property. Now third property says that x of n, which is given by any value. So x of n is any value. Now if this one, if I take the summation x of n, where k is any value from minus infinity to plus infinity. K is any value from minus infinity to plus infinity, and if I take x of k equal into del of n minus k, del of n minus k, so it will be x of n. अगर हम ये लेते हैं here, what is the variable? Variable क्या है? What is the variable here? Tell me everyone. Anyone who can say what is the variable here? What is the variable in this one? If I am taking x equals x of k del of n minus k, that means the variable is k. K is varying from minus infinity to plus infinity. So what is actually happening here? When we are taking k as a variable, that means n is a particular value with which the del is shifting. So it will be equals to del n. It will be equals to del n. And the fourth property says that the summation n equals to minus infinity to infinity, summation n equals to minus infinity to infinity, x of n del of n minus n naught, n minus n naught. Now in this one, this is the summation of x of n into del of n minus n naught. So actually it's a multiplication. We are multiplying xn. Xn is any sequence and del of n minus n naught is any another sequence. Now we know that del of n minus n naught exists only at n naught. It will be shifting by the value n naught because of this property. N minus k equals to 1 at n equals to k. So here n minus n naught. So del of n minus n naught will have the value only at n naught. Here, so this will have the value only at n naught, and rest of the places this will be 0. Now since it's a multiplication with xn, this will be equals to x of n naught. This will be equals to x of n naught. So actually this will get multiplied with this. Now since this has the value only at n naught, so whatever is my xn will have the value only at n naught. Clear? So that is how it is. By this we are getting the answer, x of n naught. So these are the properties of the impulse function. Okay? Now the next signal that we'll be studying is sinusoidal signal. Sinusoidal signal, as we know, is represented by xt is equals to a sine omega t plus phi. A sine omega t plus phi. Now this a is nothing but an amplitude. Omega is nothing but an angular frequency. And this one, the phi is a phase. This is the simple definition of a sinusoidal signal, where we know that A stands for amplitude, omega is an angular frequency, and phi is a phase. So this is how we define our sinusoidal signal. Now in this one, we know that this sinusoidal signal is periodic in nature. Now what do you mean by periodic in nature? Periodic matlab the signal repeats after an interval of time. Clear? The signal repeats after an interval of time, and that interval of time is nothing but a time period, and this is given by 2 pi by omega. It is given by 2 pi by omega. Now, whenever we have a sine wave, a sinusoidal signal, we always say that it will be periodic in nature. Hamesha it will be periodic in nature. Always it will be periodic in nature. Clear? So the sinusoidal signal T is 2 pi by omega, and it will always be periodic in nature. But the thing is, if it is continuous in nature, it will always be periodic in nature. That means it will repeat after the interval of T. That is after the interval of time period, 2 pi by omega, depending on the value of omega. It will repeat. But if we are writing the same thing in discrete, this becomes x of n. The sine wave is written as a sine omega n plus phi. In discrete, it is written as a sine omega n plus phi. Again, the t is replaced by n. It's discrete in nature, so t will be replaced by n. So it will be a sine omega n plus phi, and the period of a discrete time sinusoidal sequence is given by capital N, which is 2 pi by omega into small m. Now why this small m is present? Only because it is discrete, and we cannot have the time period for any value. हम कोई भी value को time period नहीं ले सकते, because these are the samples. This is the discrete plot, and discrete plot can have value only for the particular values. So there's a m present, which is multiplied by the entire 2 pi by omega. Clear? Now this m makes it a complete integer value, so that we can have this proper time period for the discrete sinusoidal signal. Clear? Now we need to know this n and m, this capital N and the m has to be an integer value. This has to be an integer value. Along with that, the condition for this entire signal, that is the sequence, the sample sequence, sinusoidal discrete sequence to be periodic in nature, is that this omega has to be an integer multiple of 2 pi. This is the condition. Just make a note: for discrete time signal to be periodic in nature, to be periodic in nature, the angular frequency omega must be the integer multiple of 2 pi. Clear? For a discrete time sinusoidal signal to be periodic in nature, this omega has to be the integer multiple of 2 pi. Clear? So that is the condition for the discrete time sinusoidal signal to be periodic in nature. Clear? So that was all about the sinusoidal signal. Now the next that we'll be studying is the gate pulse, that is the triangular pulse. Now the next is the rectangular pulse. First we'll study rectangular pulse, then we'll study about the triangular pulse. Now the first one, the rectangular pulse, it is given by given by pi t by tau. This is how we represent the rectangular pulse. It is the unit rectangular pulse function. So it is given by pi t by tau and the value is 1. The value is 1 for mod t greater than and equal to this tau by 2, and it is 0 for mod t greater than tau by 2. And if we are plotting it, this is t, this is 0, this is minus tau by 2, this is tau by 2, and this is pi of t by tau. Now this value is 1. This is 1. So this is how the rectangular pulse is defined. It will exist for, this is the negative value, minus tau by 2 to plus tau by 2. Clear? Minus tau by 2 to plus tau by 2. It is defined in between this value and it is an even function. Even function we have already studied. The function which is same for minus t and plus t is known as an even function. So we can see that it is existing for minus t. Similarly, it is existing for plus t also. So this is an even function. Now the next one is triangular pulse. The triangular pulse is defined by triangle t by tau. It is defined by triangle t by tau and it is equals to 1 minus 2 mod t, that is 1 minus 2 mod t by tau. ठीक है, 1 minus 2 mod t by tau for mod t less than equals to tau by 2. Not less than equals to, it is just less than. Okay, and this value is 0 for mod t greater than tau by 2, and it is plotted as, this is triangle t by tau. Now this value is minus tau by 2, this value is tau by 2. This is 1. So this is a triangular pulse. It is also an even function. Is also an even function. So this is our triangular pulse and this is our, this is our rectangular pulse and this one is the triangular pulse. Now the next is Signum function. Signum function is defined by S G N T. Okay, and the value is 1 for all t greater than 0 and minus 1 for all t less than 0. And if we are plotting it for t, this is Signum t, this is 1 and this is minus 1. Okay? So this is how it's plotted. It will be plotted for positive t as the 1 and negative t is -1. So this is how the signum t is plotted. Clear? Now the signum t is an important function and it can be written as -1 plus 2 times u of t. -1 plus 2 times u of t. Now how can we write signum t as -1 plus 2 times u of t? Just listen carefully. This is -1. If I write xt is equals to 1. What does that mean? Xt is equals to 1 matlab xt is any function which has the value 1 everywhere, for positive t also and for negative t also. So for all the values of t, the xt is 1. That means if I plot it, it will be constantly 1 everywhere. ठीक है, तो ये 1 बोल रहा है. But if I take -1, it will be plotted as negative for all the values of t. This is t, and if I have to plot -1, it will be this. That is -1 at all the values of t. ये 0 है. So for negative values of t also it is -1, and for positive values of t also it is -1. So this is plotted. Now I have to plot 2 times ut. 2 times ut matlab I can easily plot ut. I know what is ut. Ut is t and it is 1 for all the values of t which is greater than and equals to 0. This is my ut. But it is asking us to plot 2 times ut. Matlab 2 times of the entire ut. And how the plot would be? The plot would be simply twice of it. Matlab the amplitude will be twice everywhere for all positive values of t. Now we have to add these two. We have to add these two. Now let me just draw it this side and it will be easy for us to add. This is 2 times ut and this one is -1. Clear? So this is -1 for all the values of t and this is 2 times ut. Now let us see for negative values of t. For negative values of t, here we don't have any value at all. These are all 0. So 0 plus -1, 0 plus -1, if I plot, it will be just -1. For this side, for the negative side, that is negative values of t, here we don't have any value at all. This is 0. And this side, here we have value -1. So if we add these two, we'll be getting only -1. Clear? Now coming to the positive values of t. Here we are getting 2. Constantly it is 2. And this side it is constantly -1. 2 plus -1, it will be 1. Now which is our Signum function? Directly. For negative values of t, it is -1 and for positive values of t, it is 1. Hence, we can write the Signum t as -1 plus 2 times ut. Signum t can be written as -1 plus 2 times ut. Now, I guess this explanation is very much clear to everyone. Signum t क्या होता है? Signum t will have the value 1 for all positive values of t and it will have the value -1 for all the negative values of t. So that is what is the Signum function. Clear now, everyone? Okay. Now the next is the sinc function. Sinc function is written as SINC function. Now it is given by sin t is equals to sin of t by t. Sin of t by t, and it is plotted as, this is sin t. This way it is plotted. This is 1. Okay? So it is the sinc function. It is sin of t by t. It has the time period of 2 pi. It has the sinc oscillates with the period of 2 pi. 2 pi पे oscillate करता है, and it decays with increasing t, and its value has 1 at n equals to 0. So it is also an even function. It is also an even function. So that was all about the sinc function. We make use of sinc function in Fourier as well as in probability theory also. Okay? Next is Gaussian function. Gaussian function is an important function, and it is given by GA of t. Gaussian function is given by GA of t, which is equals to e to the power minus a t square. E to the power minus a t square for minus infinity to infinity. Minus infinity to infinity. It is extremely useful in the probability theory, and it is given by this way. Here it is minus 1.5. Here it is 1.5, and this value is 1. Clear? So these are the different elementary signals that we have already studied. Now these elementary signals are very important, as the most of the signals are the combinations of either of any of these two signals. कोई भी 2-3 signals के combination से आपका signal form होता है. Clear? So we need to know about each and every of these elementary signals. Now if we just have to perform the numericals. Now let me just give you certain numericals. Solve. First one. Integration minus infinity to infinity e to the power minus a t square del of t minus 5 dt. Second, 0 to 3 integration del t sin of 5 pi t dt. Third is integration minus infinity to infinity del t e to the power minus j omega t dt. Now we have to solve these questions. Now the first question says integration minus infinity to infinity e to the power minus a t square del t minus 5 dt. Now for solving this question, we are applying the impulse function properties, and we know the impulse function's property, the property which is integration xt del t dt will have the value x of 0. That is because we know that del t exists only at t equals to 0. So if we are having this particular function, integration minus infinity to infinity, e to the power minus a t square, del of t minus 5 dt. So del of t minus 5 is nothing but the function del t which exists at t equals to 5. So this will exist only at t equals to 5. ये t equals to 5 पे exist करेगा because this gets shifted at t equals to 5. So for this, after applying the property, this is integration minus infinity to infinity. This is going to be our xt. ये हमारा xt हो जाएगा e to the power minus a t square. Then t minus 5 will exist at t equals to 5. So this becomes e to the power minus a t square at t equals to 5. 5. ठीक है? So here this becomes e to the power minus 25a. Clear? Similarly, we can solve this also. Here, this is our xt. Now this is directly del t given to us. Del t exists only at t equals to 0. So this is sine 5 pi t at t equals to, which is 0. Now this one, this is del t at t equals to 0. It will be 1. So e to the power minus j omega t at t equals to 0. E to the power 0 is 1. Clear? So this is how we'll solve these type of questions. Now we have another set of questions based on the discrete time sample sequence. Now let us do those questions also. First question, it is summation n minus infinity to infinity e to the power 3n del n minus 3. Second question, it is summation n minus infinity to infinity n square del n plus 4. And the third one, summation n0 to infinity del of n plus 1 4 to the power n. Clear? Now this is how we have to solve the question. That is just by making use of the properties of the sample sequence. Sample sequence properties are very much used, and because of these properties only we can solve the numericals. Clear? Now the properties which is used in this one is summation n minus infinity to infinity del of n xn into del of n equals to what? Yes, anyone which can reply? Summation n minus infinity to infinity x of n into del n is equals to what? Del n exists only at, del n कहाँ पे exist करता है? Yes, anyone who is listening can reply. Del n exists only at n equals to 0. ठीक है? So del n exists only at n equals to 0. So if we take the property that is summation n minus infinity to infinity xn into del n will have the value at n equals to 0, that is x of 0. It is similar to the property of the discrete, similar to the properties of impulse function. So here the property says that summation n minus infinity to infinity del n xn will have the value only at n equals to 0. So similarly, this will have the value at n equals to 3. So this will be e to the power 3n at n equals to 3. And this becomes e to the power 9. This will be having the value at n equals to minus 4. So n square at n equals to minus 4. This is 16. Now coming to the third question. Third question is little tricky one, as this is del of n plus 1. N plus 1 will have the value, then n plus 1 will have the value at n is equals to minus 1. But since the summation range lies between 0 to infinity, this doesn't exist at all. It is not coming in the summation range. So this value will be 0. Are you getting my point? The summation range is given 0 to infinity, and del of n plus 1 will have the value at n equals to minus 1. So this n equals to minus 1 is not in the range of the summation. It is from 0 to infinity. So the answer is 0. So that is how we can solve the questions based on the sample sequence, by just making use of the properties of the sample sequence. Now the next topic that we are studying is the basic operations on the signals. Basic operations on the signals. Now write down the next topic, basic operations on the signals. Basic operations are on signals. Now the operations that will be studied will be on both types of signals, that is on continuous type and then on discrete also. The first one is, the basic operation is time shifting. Second one is time reversal. Third one, time shifting, time reversal, and then time scaling. Fourth one, amplitude scaling. Fifth one, signal addition. Sixth one, signal multiplication. Now we'll perform each one of the operations one by one. Now time shifting is the first operation, then time reversal, time scaling. Time shifting we already know, we shift either left or right depending on the values that we shift. ठीक है? Then time reversal कि x of t दिया है, we have to plot x of minus t. मतलब reversing the time, taking it to the negative side. That is the x of minus t. Now time scaling, if we are given with x2, xt, then we have to plot x of 2t or x of t by 2. That is scaling the time. T is given, we are scaling the time. We are plotting as x of 2t either or x of t by 2. Anything, it will be either 3t, 4t or t by 3 or t by 6, any value. Then amplitude scaling. If we are given with xt, the amplitude scaling, it will ask us to plot 2xt or 4xt or any value. So that is scaling of the amplitude. Clear? Signal addition, if we are given with x1t and x2t and it is asking us to plot x1t plus x2t. This is the signal addition, normal signal addition. The signal multiplication, again we are given with two signals, x1t, x2t, it is asking us to multiply both the signals. Okay? So these are the different operations that will be studying on the signals. That is the basic operations performed on any of the signals. Now for this, we have certain rules that need to be followed. We need to follow certain rules to solve these questions, that is to perform the operations on the signals. Now what are those rules? कौन-कौन से rules है जो हमें follow करने हैं? ठीक है? Now let us say we are given with the signal xt and it is asking us to plot x of alpha t plus beta, x of alpha t plus beta. ठीक है? So we are given with the signal xt, it is asking us to plot x of alpha t plus beta. Now the first step that we need to remember is the x of t is given. First we'll perform shifting. That is, the signal will be either advanced or delayed. Advanced means shift. Advanced means shift left. Or delayed means shift right. So this is the first step, that is performing time shifting. Time shifting, either the signal, the xt gets advanced or the xt gets delayed. xt is advanced, matlab it will be shifting right, left, and xt when delayed it is shifting right. Now if I say this is the signal, okay, this is xt. If I have to perform, it is from 0 to 2. Clear? It is from 0 to 2. And if I have to perform x of t minus 2, that means I am shifting it to 2 and it is just a delay. Delay matlab, it is just a delay. Matlab ye 2 unit baad start ho raha hai. So it will be shifting right. So it will be performed as this is 0, this is 2, this is 4. It will start at 2 and it will be till 4. It will be as it is. बस ये थोड़ा सा delay हो जाएगा. And it will be x of t minus 2. Now if I have to perform x of t plus 2, matlab it will be an advance. So it will start somewhere from here. That is from 2. It will start at 2 and it will end up at 0. This is my original xt. This is the shift right, that is delayed, and this is shift left, that is advanced. मतलब ये पहले start हो जा रहा है. So that is the reason we call it as advanced signal. And this is starting later after xt. xt यहाँ पर 0 पे start हो रहा है and here it is starting at 2. So this is a delayed signal and this is the advanced signal. So that is our first step. For any signal, agar we are given with xt, if we have to perform x of alpha t plus beta, so here we'll be delaying it by the factor of beta. Beta से हम delay करेंगे और beta से हम advance करेंगे. Whatever is the value of beta, depending on that, either will advance or will delay the signal. Clear? So that is going to be our first step. वो हमारा first step रहेगा कि या तो हम advance करेंगे या तो हम delay करेंगे. Now the next step is that apply time scaling and or time reversal. Time scaling and time reversal and or, that is it is not compulsory always, depending on if it is given. Time reversal मतलब अगर यहाँ पर negative value हुआ तो, clear? So then we will perform time reversal also. So that is not always. The time scaling depending on the value of alpha. Alpha पे depend करेगा कि हम time scaling perform कर रहे हैं या time reversal perform कर रहे हैं, और इधर both of them. ठीक है? So time scaling and the time reversal will be our second step. This is the first step and this is going to be our second step. Now in this one we need to know the value of alpha. Alpha is very important. We need to know the value of alpha. Alpha, if it is less than 1, alpha is less than 1, the resulting signal, resulting मतलब जो यहाँ से जो resulting आएगा, the resulting from the first step, the resulting signal will be linearly stretched. Okay? Now if mod of alpha is greater than 1, if it is greater than 1, it will be linearly compressed. It is linearly compressed. Okay? So if mod of alpha is less than 1, that is it is having a value 0.2, 0.3, 0.4, 0.5 or any such values like that, it will be linearly stretched. That means it will be linearly expanded. If mod of alpha is greater than 1, that is the value is, let us take 2, 3 or any such value, it will be linearly compressed. Clear? So that is how it is scaled, the time scaling. Now let us take this example again. Let us take my xt is this one, t starts with 0, ends up at 2 and the value is 1. Now if I have to perform x of first condition, alpha is less than 1, t by 2. If I have to plot x of t by 2 for this xt. Now what is the alpha? Here alpha is 1 by 2, which is less than 1. So by a factor of 1 by 2, it will be linearly stretched. Stretched means it will start with 0, this is 2 and this is 4. So it will be expanded. This becomes x of t by 2. Clear? This is x of t by 2. ये आपका stretched हो जाएगा by a factor 2. 1 by 2 is given. It will be expanded. Clear? Now, if I have to plot x of 2t. x of 2t मतलब here alpha is 2, which is greater than 1. So in this one, I'll be plotting t. This is x of 2t. It starts with 0 and it will end up at 1. So by a factor of 2, it will be compressed. ये compressed हो जाएगा. This is our original xt. This is x of t by 2. T by 2, if alpha is less than 1, it expands. It expands by the factor of 2. That is 1 by 2 it is given. So accordingly it will expand. And this is x of 2t. X of 2t, alpha is greater than 1, it will be compressed by a factor of 2. So मतलब 2 दिया है तो just half हो जाएगा. Here it ends up at 2 and this will end up at 1. Okay, so that was all about today's class. Next on Rest of the operations will be studying in the next class. Okay? Is this clear, everyone? It's clear, right, everyone? Okay. I'll call the attendance.